Hey guys, welcome back to another video. In this one, we are going to be doing some elevation drawings. Now, for the sake of the video, I'm not going to do all 4 elevation drawings from this um, project. However, I'm going to be doing, did I turn off my roof layer? Yeah, right. I turned it off for the roof framing plan. Right, so for the sake of this drawing, we're going to be doing um, let's see the left side, left elevation, and we'll do the um, north side. All right, looking from this direction. All right, but remember, for your exams, um, you're not going to be given a floor plan like this. You're going to be given a sketch like this, and usually it will be labeled saying, this elevation and arrow pointing from this side saying do this side and do that side. All right, so I have a past paper where the question was to draw 2 elevations at the scale of 1 to 50, again north side and the east side. All right, and you're supposed to show all the following: the windows and the doors, the position, the roof outline, the patio and handrail, and you're supposed to label the overhang, the window, the door, and 3 vertical dimensions on each elevation. So notice you could dimension a lot more things, but they just want 3 vertical dimensions for the elevation. All right, so this is one of the things I was talking about. CXC or your exams would limit how much you actually do, but if you know how to do the real thing, just do it, you know. Okay, so always check with your specification. So the specification tells us the height from the floor slab to the eave is 2500 millimeters. The height from the floor slab, so the floor inside of the house, to the ridge, the top of the roof, is 4700. The height from the floor slab to the windowsill, that's the bottom of the window, is 3 feet 900 millimeters. They give us the size of the windows, types of windows, sash windows, and they tell us the type of door, the size of the door. Well, we have our drawing that we will be working from. The height of the railings, we don't have any railings in our drawing, and the hip roof finish is metal sheets, so galvanized sheets. All right, so we'll be working with these specifications to do our drawing. Um, so first thing first, let's take a look at what we're doing. We're going to be doing the um, left side over here, the east elevation, no, the west elevation and the north elevation. So let's start with the west elevation over here. If we're looking at the house from this side, we're standing here, um, and the house is built in front of us, and we're looking at the house. What would we see? We're going to select this triangle thing at the top, because this is where, from this perspective, the roof meets at a point. So you'll see look like a triangle at the top, and then you'll see the wall, and then you'll see the door, and the height of the door is 2000 millimeters high, right? So I'm going to show you how to do it from the perspective of your exams, not how I would really do it. Because when I do elevations, I would usually have my floor plan, and then I would have a copy of it, and then what I would do, I would rotate it, and then I would pull along my projection lines, right? This way I am taking into consideration the thickness of my walls and the position of my door and all of these kind of things. All right, now that is how you should do it. But for the sake of your exams, you don't have your floor plan already drawn, and it doesn't make sense drawing the floor plan just so that you can pull down lines, projection lines, to do your elevation. So you should be able to look at this drawing like so and kind of do the maths. You're going to say this room here, according to this thing, this room here is, well, the distance between this wall and this wall is 150, this wall is 150, and inside it is going to be, well, let's see. If I use this side, because this side will be wider, this would be 150, 1200, all right, so that's 1350, 150 again, so that's 1500, um, plus 2400, so 1500 plus 2400, that's 39. I just want to do this on the calculator just so that um, I don't make any mistakes. So 24 plus 1500, that's 39, plus 150 again for this wall. So the total distance is 4050, but if I minus um, this wall 150 and this wall 150, that's 300 minus 300. That means the width of this room is 3750 millimeters. All right. Um, and if we actually measure it, we would see that the distance in this room is 3750 millimeters. Right. So with that in mind, and looking at this drawing, I'm going to be doing, I'll have a wall that is 4050, I believe it was, from end to end, and then there's going to be a 150 millimeter space before the door. Okay. So let me go to the wall layer. We're gonna draw it right here. So let's start with the concrete slab on the floor. I'm just drawing a line, and then I'm going to put um, a line going up like this, and then offset 4050. Okay, so let me just trim these off. All right, so let's look at the specifications. Right, the specification says the height from the floor slab, which is this line, to the eave, to the bottom of the eave actually, is 2500 millimeters. So we're going to offset 2500 millimeters. So this is going to be the bottom of my eave. Now, I don't think they gave us the overhang here. In the sketch they probably did. Yes, right. 600 millimeters is the overhang. This is the sketch. So we also have 600 millimeters overhang. So I'm going to offset 600 millimeters on that side, and that is where the eave is going to meet. So if I extend the eave, the bottom of the eave lines out to meet the overhang, that is where they will stop. All right. So let me just draw the eave completely. Let me turn on my auto mode so my lines remain straight. And then I don't know if the specifications mention the thickness of the fascia board, but the fascia board is usually about maybe 8 inches, 6 inches, 8 inches. We have been using 8 inches, so that's 200 millimeters up, and then I'm going to come across all the way across. All right, and then I could just trim out this in here. All right, so that's my fascia board. um this line just represents my overhang. Now I know where my roof is. I don't need it anymore. And then remember that um in the middle of the roof is where these two hip lines are going to converge. We're going to meet each other. All right, so we could just pull a line up in the middle right here, like so, and then we could what did it say about the specs, about the height of the ridge from the floor slab to the top of the ridge is 4,700. So from the floor slab, we're going to offset this 4,700. So this is where the roof is going to be. So notice that they did not give us a pitch, they just give us the heights of the roof, and we don't need this line anymore. All right, we don't need this line anymore, and we don't need these lines anymore, and we could delete them or trim them off because we already severed it here. So delete, and let me trim this off so it will leave the corner here. All right, so this is what we would see from the front. So this is the floor slab of the house. Now your house always has a step up. So let's do offset. Um, let's do 16 inches maybe. So we'll offset, let's say 16 inches. We can make it you know, a foot and a half, 2 feet, but you need to put stairs and all that. So let's say 16 inches, where I can put two steps. 16 inches, 8 inches is 200, 400 millimeters, 16 inches. So we'll do that. Now this is the floor of the inside of our house. This would be the ground on the outside. Right, so I'm just gonna extend some lines out like that to be our ground line. And let's think about it. If you are standing outside of this house, can you see the floor on the inside directly with your naked eyes? No, you don't have extra vision like Superman to see through this wall and see the floor. So that means this line should really be a hidden line. Okay, so let's 20. Okay, and then we'll make it a little thinner. 20. All right, so there we have that. So according to our drawing here, there's the wall is jammed, the door is jammed right up to the wall, and the wall is 6 inches thick. So that means the door is 6 inches from the wall, the edge of the wall there. All right, so we'll offset 150 millimeters like so. And then what did the specifications say about the height of the door? Well, we'll use my specifications. It says that the height of the doors is 2000, right, 2000 millimeters. So let's offset 2000 millimeters from bottom, and then 900 millimeters wide like so. All right, so we could trim this off, trim that off, draw a line across the top like so, and we can get rid of this. All right, so this is where the door is going to be, and this is what you would see. So what I'm going to do, I'm going to just switch this to my actually I'll leave it like this. Leave it on this wall layer, and then we're going to go to the design center, and I'm going to pull out. By the way, if your design center is not open, you could type AutoCAD Design Center, D Center, ADC Center, AD Center, and it will pop out, right? English US Design Center, and then in the home design blocks is where I would find my door. So I have some fancy doors here. I can pull this out. This space is 2000 millimeters high by 900 millimeters wide. Is my door the same thing? For let me put this on the correct layer so I can measure this. So this is 914 by 2131. So what I'm going to do, I'm going to rescale this from 914 to the width of this opening, 900. So scale, base point, reference. So the reference length is 914, and then the new length is 900, and then it should be referenced correctly, right? 900, but the height would have changed, but not nearly enough. So the height is now 2101. If we scale it and change the height, then the width will change. So what we have to do, or what I do, I explode it, and then I use the stretch tool, select these lines, these vertical lines along with this one, enter, select hair, and then I'm going to shrink it. But how much do I shrink it? Let me just put on my auto mode. How much do I shrink it? So it was 2101, and I want it to be 2000, so that's a difference of 101. So now it's shorter. So if I measure it, it should be 2000, and the width should be 900. Put this back on my, I wonder if I could join this. J, enter. Nah, didn't join. I could group it, but I'm not going to go through all that right now. Put it on my doors and windows layer. So we'll fit this in its space. Turn off that auto mode. Fit that in its space right there, like so. And the next thing I would do is put a hatch in the roof. I'm going to use this. Actually, I'll use this one, but I'm going to make it a little bit closer, 500, maybe even closer than that, 250, right? And then I'm going to change the angle. Right now it is 45 degrees. So if I add 45 degrees more to that, it should straighten itself out to 90. 45 plus 45 is 90. Right, so there we have my galvanized pattern. I could have used this one also. You know, it works. It all works like so. Might have to change the scale. All right. So what did the question say to put in? I believe that's everything on this side of the building because it's not very complicated. So if you had more things like windows, a porch area going, and then you have a door behind there and all of that, like this sketch did. This sketch was very interesting. It's not that hard. So you would be drawing this wall. You see the railing going across here. The door would be behind the railing, and you have your windows here. They didn't tell you how far apart the windows were from, the door or the wall, but they showed you the width of the window, W2, W1. You could check it in the specs, and you would see the size of the window. But it's basically the same thing. If you're standing here, you would see this wall with two windows. You would see this wall with a window here, a window there, and a door in the middle, a double door. And if you're standing here, you would see this wall with a window. You would not see this window on this wall, all right? Because that's to the side. You do your roof with the measurements they give you, your bottom of the eave, bottom of the window sill, and all that, and you're done. Okay, so that's it for this one. We just need to put in some dimensions, 3 vertical dimensions, they said. So let's do the distance from, let's do the height of the door. All right, let's do the distance from the floor to the bottom of the eave, because these are all the measurements that they gave us. To the top of the ridge, and that's 3 dimensions, 3 vertical dimensions. Now if you had windows, you could dimension the windows, the distance from the ground, from the floor slab to the bottom of the window, to the top of the window, and all of that. I would even put in this distance, this step up distance here, which we said was 400. All right, and the reason why I made it 400 is so that I could do offset 200 twice. Wait a minute, this one. I'll do a line. I'll do a line right here. This is going to be my stair. All right. So I have some stairs leading up to my door. All right. And that's pretty much it, because our drawing is pretty simple, but the principle is the same. If it's a much more complex building with railings and all of that, and there's a nice video on the internet you could follow doing this very paper. All right, so I'm going to do one more. Let me do I said I was going to do this side. So imagine we're standing here looking at the building. We're going to see the roof, which is going to have this flat ridge at the top with these slopes coming out this side, the eave, the bottom of the eave, and then we see this wall with a window in it, 4 feet wide. So same thing. We're going to draw draw a line. This is going to be represent the outside, the ground outside, and then I'm going to offset this 400 for my step up, and then as it says in the specification sheet, from the floor slab to the bottom of the eave is 2500. So that's the eave. You need a line here to represent my wall. What's the size of my building? Let me finish putting in these measurements first. So we have the height from the floor slab to the top of the ridge, 47. So offset 47 from here to here. And then what's next? Yeah, unreal. Okay, we don't have all of those. So what do we see? We have if we add these up, this is 3000, 3000, that's 6000, plus 150 and 150, that's 3300, and then 150 in the middle here for this wall. So the entire width would be 3450 plus 6450, sorry. So I could offset 6450 from this line. Oh, it's taking me over there. Let me extend these lines. All right, like so. All right, so this doesn't need to be all there. That doesn't need to be there. And so this is the bottom of the eave. And remember, we have the overhang, which is 600 millimeters, 2 feet. So the eave is going to come out to meet those lines, right? So once we have that, I can get rid of them, and then I can do the eave, 200 millimeters, 8 inches, come across, what was it, 4,000, no, 6,450, yes, no, it's 6,450 plus 600, no, plus 1,200. Anyways, I could just offset this 200 and close this off at the side. Alright, so now I could get rid of these lines. Notice I did it a different way this time, right? Because I'm not thinking about remembering steps here. I'm just thinking about what the goal is and how I can achieve that goal. All right, I know what I'm trying to do. Okay, so this is where the roof is. Um, where exactly do these lines come across? Now this is the part where having a floor plan where you project down your lines, the lines will be projected down here and here. So I would know exactly where um, these lines are. So this is one way you could do it. If I drew a roof, um, let's say, oh, wait a second. If I have this line and I drew a line here, right? Let me just copy this. You could actually do this in an exam, you know. That's the overhang. These are the walls, right? And then what we can do is what we said was the length of this side, the width of this side. $5,250. So let me just extend these up. 5,250, like so, right? I don't think I need these actually. So 5,250, let me just copy this one. So essentially what I'm making here is the roof of the other, of the property, of the house. Alright, so I don't need these anymore. So what I'm gonna do is construct the roof, like so. Right, it doesn't need to be perfect. I don't need to trim out and all that because this is just temporary. I'm going to pull a line down, like so. So where it meets this, that's where, that is where the ridge is going to start and end, from there to there. Alright, so we could just trim this up, like so. Alright, and I don't need any of these anymore. Okay, so I have this. I need to make this hidden, change this line type scale to 25. I believe I used. There's going to be a window right here in the middle of this room, so 3,000, and then I have 150, 150, so 3,300. And the window is going to be in the middle of that, so 3,300 from this side, and the window is going to be right in the middle of that. So the window sill is 900 off of the ground according to the specifications, the height from the floor to the window sill. So offset 900, and then what's the height of the window? This is saying my window is 1100 millimeters high, but in my specifications I have my windows at 1200 by 1200, so I'll go up again 1200, well, not again, but you know. So where is the middle of this room? Quick tip in technical drawing: if I want to find the center, annotate center line, boom, boom, that's the center. You could also just draw an X from here, diagonal lines from the corners, of a rectangle or square, where the cross in the middle, that's your center. Okay, so we have the center of the room. So if I go 600 this way, 600 this way, I don't need this line anymore. I don't need any of these lines anymore. I can join this line with that line, and then I could bring down lines perpendicular. So that's my window. All right, and then I could use my design center, pull a window in. I believe in my specifications I said that the windows are casement, which means that they open outwards. What I usually do, I just rotate these AutoCAD stock windows. If it's casement, I mean, this is designed to look like a sliding window, sliding upwards, right? Now that I turn it sideways, it's sliding across. But who is to say that this window doesn't open outwards, right? So you could draw it manually, or you could just take the shortcut. Let's see if this fits. 914. It really should be 12. So let's use the scale tool. Reference 914. New length is 1200. Let's see if that actually works. Sometimes it doesn't. You have to do it twice. See, 1201. 1201. So let's do it again. Base point. Oh, sorry. Scale. Base point. Reference. So the 1201, that's the reference length, and I want it to be 1200. So let's measure it again and see. No, it's correct. So let's put this on the correct layer and put this in place where it should be. Then I would just go to the hatch 45 degrees, like so. Alright, I don't need this line anymore because you can't see the wall, and then I'm not going to draw the hidden line to represent the wall. I'll just leave it as this. Same thing as the other one, some dimensions. From floor to there, I'll put this on the opposite side, and then I would continue dimensioning upwards. Bottom of the eave, I can do chain dimension, instead of doing the the one on the outside. And let's do distance from the window sill to the ground, to the floor. Let's do the height of the window, right? There's a lot of things you could dimension. Okay, and then for the sake of the drawing, let's do this part manually. Single line. Let me do this is not southeast, west elevation. West elevation. Oh, right. Draw a line and scale tool 1 to 50. Was it 1 to 50? Alright, let me copy this. Let me copy it the right way. Like so. And I believe this is the north elevation, if I'm not mistaken. North elevation. So I'm gonna put these maybe on pages for themselves. So I'll call these, let's see what fits first. So can both of them hold? I think both of them could hold on the sheet. Normally the drawing would be so big that they can't. So I'm actually going to, you could move things in the paper space just like in the model space. So I'm going to put both of them in like this, and yeah, scale is 1 to 50, titles are there, candidate number, etc. And then we'll just call this elevations. Right, so plot this. Again, the the concept is the same. It doesn't matter the size of the house. If you're able to kind of envision how the house would look looking at, looking at the house, outside of the house, standing outside looking at it, and you're able to envision that, doing something like this is actually pretty simple. All right, so we have our elevations here. So that's pretty much it for this video. We'll see you in the next one. Hopefully I'll be doing a section drawing. Yeah, so until next time, peace.